So the solution to this system of equations, I came out with 3 for the x and 5 for y. I can check by plugging those numbers back into both equations to make sure they both check out, and sure enough they do. My third and final example for substitution method is 3x plus y equals 5, and negative 2x minus y equals negative 1. In my first two examples, I'd taken the first equation and solved for x. However, in this instance, it's going to be easier to solve for y, because y is already by itself. So I'm going to subtract 3x from both sides to get that y equals negative 3x plus 5. I'm then going to take negative 3x plus 5 and substitute it for y in the second equation. So negative 2x minus, in parentheses, negative 3x plus 5 equals 1. Again, don't forget to distribute that negative. So negative 2x plus 3x minus 5 equals 1. Combining like terms, I get x minus 5 equals 1. Lastly, I'm going to add 5 to both sides, giving me x equaling 6. My second substitution, I'm going to take that 6 and substitute it in where I have x. So y equals negative 3x plus 5 now becomes y equals negative 3 times 6 plus 5. Negative 3 times 6 is negative 18. Negative 18 plus 5 gives me that y equals negative 13. My solution is then 6 for x and negative 13 for y. Again, I'm going to double check myself and plug those numbers into both of my equations to make sure that is the correct solution for my system of equations. And it is. The next way that we learned how to solve system of equations was the elimination method. Note card number 15 was the elimination method. With elimination, you get rid of one of the variables by adding or subtracting equations. You may have to multiply one or both equations by a number to create variable terms that can be eliminated. My first example, I have the system of equations 3x minus 4y equals 1 and 5x plus 2y equals 45. I am going to be multiplying these. The first one is actually okay just how it is. However, I'm going to multiply the second equation by 2. That produces 10x plus 4y equals 90. The reason I did that is because it makes it so that the y's will then eliminate when I add the equations. 3 plus 10 becomes 13. 90 plus 1 becomes 91. I'm going to divide both sides by 13, and I get that x equals 7. Then I'm going to take that number and plug it back into one of the equations, and I'm going to solve for y. When I plug it back into that first equation, I get 3x minus 4y equals 1. Then 3x times 7 minus 4y equals 1, which then means 21 minus 4y equals 1. Subtract 21 from both sides, I get negative 4y equals negative 20. Divide both sides by negative 4, and I get that y equals 5. So my solution is 7 for x and 5 for y. Of course, I double check myself, and of course that's right. My second example for the elimination method I have 4x plus 9y equals 3 and 8x minus 3y equals negative 8. I have two sets of numbers written on the on the left-hand side. The first ones are negative 2 and 1. If I multiply the first equation by negative 2 and the second equation by 1, I'm able to eliminate the x values. If I multiply the first equation by 1 and the second equation by 3, I'm able to eliminate the y values. First I'm going to eliminate y. So I multiply the first equation by 1 and the second equation by 3. When I multiply the second equation by 3, I get 24x minus 9y equals negative 24. When I add 4x and 24x, I get 28x. 9x and negative 9x cancel out. and 3 minus 24 is negative 21. I then divide both sides by 28 to get x equals negative 21 over 28, which I'm going to simplify by dividing top and bottom by 7 to x equals negative 3/4. So I have my x value. I can now multiply those same equations by my other set of numbers, negative 2 and 1, to eliminate for x and get my y. So if I multiply the first equation by negative 2, it produces negative 8x minus 18y equals negative 6. In the second equation, I just multiply it by 1, so it remains the same. The negative 8x and regular 8x cancel out. Negative 18y minus 3y is negative 21y. Negative 6 and negative 8 makes negative 14. Dividing both sides by negative 21 gets my y all by itself. So I find that y equals 2/3. So my solution is x equals negative 3/4 and y is 2/3. My third example for the elimination method is 2/5 x minus 1/2 y equals 6, and 4/5 x plus 3y equals negative 8. You know how we love those fractions, so the first thing we're going to do is get rid of them. I'm going to multiply the entire first equation by 10, because 10 is the lowest common denominator for 5 and 2. I'm going to multiply the entire second equation by 5, because the lowest common denominator is 5, since 5 is the only denominator in that equation. That now gives me a beautiful 4x minus 5y equaling 60, and 4x plus 15y equaling negative 40. I now multiply the second equation by negative 1 so that I can add to eliminate the x values. So 4x minus 4x is eliminated. Negative 5y and negative 15y becomes negative 20y. And then 60 and 40 becomes 100. I divide both sides by negative 20 to find that y equals negative 5. I then go to one of the equations and put in negative 5 for y and solve for x. And when I do so, I get that x equals 35 over 4, which is the same thing as 8 and 3/4, and then my y value was negative 5. My fourth and final example for the elimination method is 4x plus 3y equals 4, and 6x equals 6y minus 1. First thing I'm going to have to do is get it converted into the ax plus by equals c format. So I'm going to subtract 6y from both sides in the second equation. So now I'm dealing with 4x plus 3y equals 4, and 6x minus 6y equals negative 1. Again, I have the opportunity to multiply by two different sets of numbers. First time to eliminate x, second time to eliminate y. If I multiply the first equation by 3 and the second equation by negative 2, it gives me 12x plus 9y equals 12, and then negative 12x plus 12y equals 2. When I add those equations, the x's eliminate. 9y and 12y becomes 21y. 12 and 2 become 14. I then divide both sides by 21 to get y equals 14 over 21, which is simplified to 2/3. I then multiply those original equations, the first one by 2, the second one by 1. I get 8x plus 6y equals 8, and 6x minus 6y equals negative 1. When I add the equations together, I get 14x equaling 7. Divide both sides by 14, and x equals 7/14, which is the same thing as 1/2. So my solution to this system of equations is 1/2 for x and 2/3 for y. This concludes the test review for note cards 1 through 15. If there's anything that I covered that you need to watch again, now would be a good time to rewind. You can also go to the digital locker on the Garland ISD gradebook, and there's a PowerPoint presentation with additional information. Good luck on your test!